Okay, now we're going to look at some additional examples. In this case, basketball, shooting hoops. So we have a basketball player who has an 80% free throw success rate. So 80% of the time, the player makes her shot. How do we simulate whether she makes a foul shot? How many shots might she be able to make in a row without missing? So you're going to describe how we're going to use a random number table to conduct this simulation. Well, a component means taking one shot, and we get a random digit of 0 to 9. Now, why? You could say, well, wait a second. The percentage is 80%. Shouldn't I use 0, 0 to 80? And I could. But if I can use less digits, that's actually better. So I'm going to use 0 to 7. There's 8 outcomes right there, and that represents her making the shot. And 8 and 9, that's 20% right there, would represent a miss. So the trials mean taking a shot till she misses, and since a miss is 8 to 9, then stop on the first 8 or 9. Your response variable is the number of shots made before the miss. And the statistic would be the mean number of shots made. All right, so I could just do my random number table, count until I get an 8 or a 9, and that's how many shots she made. And I could do multiple trials and then report my estimated statistic. Well, my statistic, but my estimated percentage. All right, how would our simulation procedure change if her success rate were only 72%? In that case, now I really do want two random digits. So I'm going to let 0, 0 to 71 represent a good shot and 72 to 99 a miss. And the trial pretty much stays the same, except the miss is now from 72 to 99. So I stop on the first pair of digits that is 72 or higher. So let's say she's got 72%. How many shots might she be able to make in a row without missing? How would a trial in our response variable change if we want to know how many shots she might make out of 5 attempts? So we're changing this top problem to shots out of 5. So the trial is now looking at just 5 pairs of digits. And the number of shots she makes out of 5 attempts is a response variable. And the number of pairs from 0, 0 to 71. Remember, anything from 72 on higher is a miss. How would the simulation change if we want to know her score in a 1-on-1 situation? That means she gets to take a second shot only if she makes the first one. So we're going to look at the first pair of digits. If the first pair is 0, 0 to 71, she makes that shot, and then we get to look at the second shot. And we stop at 2 pairs at most because it's only a 1-on-1. You don't get to make 5 free throw shots. The response variable would be the number of points she makes in a 1-on-1 situation, and the statistic would be the mean number of points. Now here's an interesting one. We're going to say she has a 65% free throw success rate on her first shot, but if she makes it, she's a little more confident and she actually does a little better on the second shot. Not only that, she knew she had the right kind of throw on the first shot, so she knows how to take the second shot. So the component's pretty much the same, taking a shot, pair of digits, 0, 0 to 99. For the trial, we look at the first pair of digits. If the first pair is 0, 0 to 64, she made it. And then we go ahead and look at the second pair of digits. If it's 0, 0 to 79, she made the second one. If it's outside of those for either one, she misses. So the response variable is the number of points she makes in a 1-on-1 situation. And the statistic is the mean number of points. So let's go ahead and run a simulation for this scenario. And we're just going to do 10 trials using the random numbers below. And it actually doesn't take very long because remember, we're at most looking at 4 digits. So for this first one, she makes the first shot, so she gets a second throw, and she made it. So she got 2 points there. Here she missed, so we're done because she doesn't get to do it again if she misses. She made it, done. Made it, done. Made it, done. Misses. Okay, so that's done. Made it, done. Made it, done. Made it. She tends to do them in pairs, doesn't she? Done, a miss. And so let's see, that's 10 trials. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And she got a total of 14 points. So the statistic is 1.4 points. All right. So what I'd like you to do is use the rest of the random numbers to do another 10 trials and provide the new estimated statistic. Remember, I've only done 10 trials here, and simulations should really be 20 trials or more.